computer. Okay. So, welcome everybody. I feel a little bit out of sorts. I'm sitting in a hotel room in Milwaukee. I'm up here for a training on a 3D scanner that we use in our manufacturing lab at Northern. Um, and had my head in a screen all day long. Playing student for a while. It's a different feel. Um, but I'm excited to catch up with all of you guys. Let me just real quickly share the agenda. Last time we had such a robust discussion, we really didn't get a chance to talk about the science paper that we're, um, sorry, trying to move some things around there. I think we can all see the agenda now.
Yeah.
Yeah. Um, So I hear quite a few bells. So folks are just now joining us. I just got the agenda in front of us. Um, and so we usually begin with some user experiences. I'm glad Connie and Neil are here. I want to kind of address issues you're having with the glove. Maybe we can talk later if we need more time. Um, there's yeah, it was continual kind of design improvements. I'm going back and forth with my final app designer. It's just uh, I'm frustrated that we don't have something in front of you right now, but I'm trying to push everything to make it as easy as possible to use the app. Um, but I hope that we should have time then for for a neuroscience presentation, right? And we talked a little bit about why this is important. Um, there's a lot of buzz about these kind of Ozempic, Wegovy kind of weight loss drugs, diabetes drugs, seemingly having like an amazing impact across the body, and and Parkinson's and kind of other brain issues are apparently seem to be kind of good candidates for some of these treatments. So I'll talk largely about kind of the why they're good candidates, but also it's been maybe like similar things with other treatments. The the clinical trials have not yet really hit on kind of the right population or the right combination of drugs, and so the promises haven't led to real results. But it's still something, I think we should all be aware of. It's a promising thing that yet remains elusive and on the horizon. Uh, But it might give us a chance to talk a little bit more about kind of the neurobiology of Parkinson's. It's related to kind of mitochondrial health, which is related to red light therapy we talked about before. But we'll get into that when we in that part of today's talk. But I also want to make sure that you guys have this on your agenda for next time. So on July 6th, um, Tommy and Emmy, the young women at Rice that are kind of invented this kind of Connections Glove Foundation, they'll be here at our Zoom session talking about the benefits of their glove, and we're now kind of um, we're in active conversations about how best to collaborate. So we've been right now kind of moving along parallel paths, um, and uh, I've been now promoting our stuff and a couple clinical trials and trying to raise funds for those things. And also the Rice group are also interested in clinical trials. All of our contacts are in Houston. Um, it seems strange to try to run parallel clinical trials on the same technology. And so we're trying to find ways to kind of come to the best possible. Something we want to throw into a clinical trial should be, well, shouldn't be thrown in. Something we want to enter into clinical trials should be kind of the best glove that we can put forward. And whether it's our current design or our modified design or their design or some combination of the two, um, we're in conversation with the neuroscience and neurology and neurosurgeon folks at in Houston on those things. So we'll get into that a whole lot more deeply. But I'm hoping to also get some advice from you folks, right, about kind of best way forward. But the best thing is to hear from the originators of that glove, right? Um, and and I know, and Ken Heidkamp is one of the few folks. I mean, just like Kanwar early on was wearing our glove along with Toss's glove, Ken's been able to encourage both groups to develop their ideas. So I'm also hoping to hear from Ken at any time if you want to chime in, Ken, about
Yeah,
your
I haven't been in contact with them much lately, but they did share a new design that they're working on. I can't say more because I have an NDA, but I'm sure I hope they'll talk about it on the 6th.
Okay, cool. That makes sense. Thank you. Um, uh, so yeah, that's the agenda. I guess yeah, and let me just on the app business. So let me kind of try to take you back to our homepage. Um, I do want to um, you know thinking I was a day or two away, so I'm beginning to some of the hoops that we have to jump through, of course, to post an app is we need a privacy policy. That privacy policy is now there that you can click upon. It's about um, well, I guess first of all, you do not need the app to run the glove. The app is an assistant, right, that allows you to record the glove, to change the glove settings, to record the glove settings. It also allows you to monitor your own gait and your voice. And if you choose, you can opt in, and then that information can be shared with my database. And then my group and I can try to use that data, depersonalized, anonymized, to try to tune the glove to the best symptoms. Um, and we need a whole lot more discussion of that. But I mean, I'm just showing you that I'm kind of this is in preparation for kind of releasing the glove, kind of hopefully simultaneously. The glove apps are at the two app stores, at the Play Store for Google and the Apple Store. Um, I've tested both of these things internally. I can add you people. I can add folks internally as well. There's just a couple more hoops to jump through if I add you as internal testers, and I'd rather try to erase those hoops, right? And that's the current kind of logjam I'm in right now. And it's not. It's just a matter of kind of time and coordination with my app developer. Um, who's on the job market, and I'm not getting kind of day-to-day feedback from him. Um, so 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 like I said, the app is ready, but it's not in your hands because I've yet to kind of jump through all of the hoops needed to remove hoops from people that just want to take it out of the store. Um, so let me, yeah. So I would also, and again, once things come forward, I would like, kind of feedback on the privacy policy, any questions people might have about um, any questions or misgivings. Um, and again, it's an opt-in strategy. So upon using the app, you're not sharing anything with anybody. You have to kind of voluntarily, move a slider over to opt into the research program. And then also at any time you can opt out and ask me to, erase the data.
Steve, are you looking for any testers among us
Um,
to participate in anything like that,
Okay,
or,
I found this on the
oops,
web for looking for.
sorry.
um,
Or would you rather just hold off and for better timing?
yeah. So thanks, Lauren. And just, yeah, I think I've had enough internal tests that I'm confident that what's there, at least as far as the functionality goes.
Uh-huh.
And so Yeah, I'm really hoping that this week, even though I'm traveling this week, that I can really close the deal with my other app developer and kind of jump through those final hoops, and then I can just put it right up on the Play Store and or the Apple Store, and you'll just be able to
Right.
to grab it without
And
any
Okay.
so
extra.
you'll send out an email when you
I
do
will, I
that?
will, I will. Yes,
Okay.
it'll be one of the happiest days of my summer when that happens. Yes, yes, I will. Yeah. Um,
Well,
so
quality ought not be rushed.
thank you, Jim, for your yes.
It all too often is.
I second that.
Hmm.
I worked in a big corporation and there were times when somebody said something had to happen and then everybody scrambled to make it happen, but it wasn't the right time. So,
Well, I really appreciate your patience, you guys. Thank you for that.
We appreciate your due diligence.
Yes.
The presumption is you can improve the glove by dialing it in. Have you done it in any case?
Um, I've only done it to kind of to ease kind of the wearability. People that thought the motor amplitude was too intense. So I was able to dial back, the amplitude, Ken, without having, without them losing efficacy of what they were getting from the glove. But as far as changing um, the burst duration or changing the pattern duration, no, I have not explored those. Yeah,
Yeah.
yeah, and um,
On the world.
yeah, yeah, yeah. Um, So, and other subjects they want to talk about on the glove, so people saw the agenda. So July 6th, other glove manufacturers will be talking with us. Um, yeah, and speaking of other glove manufacturers, right? I mean, so I think last time I mentioned, so Ken Toronto and I had talked with the new shoe guy in Zurich, and he had kind of turned us on to a glove manufacturer in Germany. And Connie, you've had some correspondence with this guy, right?
I have, yeah.
The CureTech.
Yeah, he said he spent many years with Toss at Stanford and when he was in Germany. So he thinks it's the same algorithm. It looks very different. You can see the photo on his page.
Yeah.
He doesn't, he was supposed to get back to me about how they were dealing with people on the West Coast and what the cost. He said it'll be a lot more expensive.
Hmm.
Yeah. And the only reason we're looking at it is because we're having trouble with, your gloves.
Yeah, yeah, yeah. Um, yeah, so I'd like to send you a new pair, but maybe can we talk after the meeting's over?
Yeah,
Connie,
for
we
sure.
can yeah, yeah.
Yeah, we don't need to take the time.
Okay. Um, yeah, so I think last time I showed a picture of the glove that Connie's talking about from CureTech. It's got kind of clamshell, kind of oxygen sensors. It's a little bit probably, t snugger fit on the end. And they moved the box right off their wrist and kind of up onto the back of the hand. Um, yeah, and that can be done as well. With kind of the two Kens that moved that onto wrestling gloves. And I know that's the Rice glove we're going to talk about in 2 weeks also has the box moved up. And again, I think the advantage of that kind of Connie Neal also is that kind of shortens the wires in some cases. Um, so I mean, the less wire, the less there is to get
Yeah, and I don't think they use Velcro, which we don't, we have to scotch tape it every day.
Gotcha. You mean
Yeah.
at the wrist?
Yeah.
Yeah, yeah. Um, yeah, so I've gotten some good advice too on the, all right, I think we just got, we're using some fairly weak Velcro, and I apologize for that. So people are kind of pushing some elastic bands on us, and so yeah, we're the glove designers themselves, rather than just electronics. Yeah, so Ken H, do you want to say what you're showing there?
Yeah, this is the version where I took your components and put them on a weightlifting glove.
Hmm.
So it has the Velcro, and I put Velcro on the box and the glove, and of course I had my straws to direct the wires.
Yeah.
I had to cut these down because the last set of fingertips I got, the wires were a little bit too short.
Hmm.
but then I use
It's
the
so black. Ken, it's so black. I mean, you can hardly see anything. Is there any way you can have light shine on that? There we go. You can see a little better now. Yeah. Uh huh. Thank you. Yeah.
and I replaced the Velcro with the new strips,
Gotcha. Yeah, with the silicone pieces. And
silicone. Yeah,
yeah, yeah. And the wrestling glove is it held on by Velcro itself? There's a Velcro piece that
and
yeah,
Claire.
yeah. Can you guys see that? It's I think because your background gets blurred, Ken, when I think the zoom focuses in
Yeah.
on one thing at a
Your
time. But
T-shirt is black and the glove is black, so it blends together.
We did the same thing.
yeah,
there's a pair of Kens there. Yes.
Nice. Very nice.
The glove goes on with Velcro.
Yeah.
I use the weightlifter's glove.
And it's probably stronger Velcro than what we're using on our fabric. Yeah.
Well, I actually had to cut the Velcro down. I had too much Velcro. It's so
Uh-huh.
hard to, because once you
Gotcha.
put the
To peel
gloves
off.
on,
I see.
I just have a little bit.
Gotcha. Yeah, so I'm not sure we have any of our sewing crew on here, but that's again. Oh no, so Min is here. Sorry, in the middle. So good, good. So she's seeing this and we're recording this. So
I mean, basically, you take your device, take it out of the sleeve, put the box on the glove, and then everything else just flows through. We sewed this here and Velcro this.
mhm,
I like the way the wire is really nice now, the way you've got them welded, soldered.
yeah,
It
yeah,
just
and
stops it from slipping around.
right, right. I agree. Yeah. So we've been going back and forth about various designs, and we should if we're going to make continue with that, we should also I think go in the direction that you guys are advertising, right? And just maybe offer both and see what people want. But yes, right.
Julie, did you replace some of the Velcro with some silicone straps?
Who, me?
Yeah.
Yes.
Oh, look at you. Another
I,
modification.
but I'm not the only one that's done this, right?
They come that way now.
It's the way they
That
come
makes
now.
sense.
Yeah, yeah, yeah.
Yeah.
But um, I can also send some to folks. Or if you want to see, if you want to see kind of links for kind of the most current stuff that we're using, I do. And I'm not sure if I advertised this last time. I've been teaching teachers how to make these in their own classrooms and to make these workshops. So that has a full kind of parts list of everything on the glove, including these new silicone strips. So do you still have Velcro fingertips, Lauren?
Yes, I
Gotcha.
do.
Gotcha. Um, and some people prefer the Velcro, which is, so again, there's so many kind of possibilities to go down. So um, I'm going to share my screen one more time because I want to show people this kind of maker manual because clearly, I mean, so what have we just seen here, right? So people are tinkering with these designs. Hallelujah, right? And so I want to show people kind of what's there on our current design page, right? So, um, is this true? Am I back to our,
Yes.
okay, cool. And so as I scroll down a little bit, there's this Espanola GloveWorks Maker Manual. Um, and And so with this now, I've trained kind of 14 teachers in northern New Mexico from uh,
Awesome.
from many, many different schools, right? And it's kind of 5 chapters, and I think right now we're talking about chapter 2, you guys, right? And so um, that's basically how to make one of those, right? And if you can make one, you can make you can make 8. And so there is the 3D design file for how to make a finger pad. That's what the battery looks like. And there's the link to where I bought the battery. Here's the link to where I bought the motor. Um, The cables are custom designed by this Chinese company that would take a little bit more maybe help from me, but you can kind of see, where they come from. These are very small connectors that get put onto the end cable, so those are kind of custom designed. The kids use these wire cutters and this heat shrink tubing. Um, and then these are their soldering tools, the heat shrink tool, and then to kind of finally get to the what Lauren's asking about, these are the silicone bands that we're now using at the fingertips, Lauren. Okay.
Could I order them through you? Because I ordered them through the internet and they never came. I paid $10, but I haven't gotten them.
Oh, that's rotten. Yeah, yeah.
Yeah,
So yeah, I can send you some. Yeah, can you send me a note?
sure,
Yeah,
absolutely.
yeah,
May
yeah.
I say, I think, pardon me, Steve, that when Laura and I were consulting, I had ordered them on Amazon and it was a piece of cake that came the next day. But Lauren found a better deal or something. She liked the color better or something. She ordered them from, not from Amazon. So I'm going to say Amazon. These ones he's showing right here, that Amazon page, super easy to get and they were great.
I wish I
No
knew that
problem.
beforehand, but that it wasn't gonna, that I was off in the weeds with the vendor there. But
Right, right.
anyway, yeah, if I could buy them from you, Steve, I can replace them, and
Okay,
I think it would be more comfortable than the Velcro.
gotcha. I
They
think so.
are. They're very comfortable. Very
Yeah, and
nice.
they also don't stick together, and so Julie, it looks like you trimmed yours as well, right? Once you found, the
I
right.
did.
Yeah,
I
yeah.
finally I decided this is it. This is the length that they need to be, and I snipped off the ends, and nothing bad happened. They still hold them together really nicely.
Cool,
Good.
cool. Um, and so, um, yeah, so there's lots of other, well, again, but this is, I mean, ideally, I meant these sessions here to be some combination, right, of folks wearing the glove, testing the glove, and also kind of makers of the glove. Um, and trying to democratize this as much as possible, to open source it as much as possible. Um, so kind of all components of the glove and the motor circuits and how to write code and how to build printed circuit boards, how to solder the computer onto the printed circuit board, and yeah, and then a whole lot more on how to write code, and then also how to write the app. Um, and so we begin in the simplest possible way by just making a cat vibrate, or cat purr, and then going from
Oh,
if you can make a cat purr, then you can make a fingertip, purr.
very cool.
Yeah. So I just wanted to show you that that's a resource that's there. You guys, if you have questions about components of the glove, um, that's just hanging. And again, I hope there's not, too much there. There's a trifold brochure if you want to share information about the glove or want to print one, or if you, uh, you know, if you don't have access to a good printer, you can ask me and I can send you a bundle of these things. If you want to share them with, say, some assisted living facility or some school in your area, um, these are just things to help us kind of um, educate people about alternative treatments and share our work. Um, Not trying to sell people. So um, let me just stop the share there.
Steve, I'll just show you this one.
Yeah,
This is the rice glove.
gotcha.
So it's a glove within a glove, and the motors are in the fingertips.
Uh-huh. And your fingers slide into some cups at the end that kind of give you good contact with the motors?
Yes,
Yeah,
it's
gotcha.
like two gloves, a glove and a glove,
Uh-huh.
and then the control is on the back here. So it's all black, but they've really slimmed it down.
Yeah, yeah.
The trouble is it's one size glove,
Hmm.
and when I get one on, I need help putting the second glove on.
Gotcha.
But nice design.
Hmm. Hmm. Cool, cool.
Hey, Steve, I have a question.
Yeah.
My Parkinson's is primarily in my right foot and leg. Has anyone experimented with using these on your toes?
Um, yeah, not to my knowledge. I mean, although what we talked about what we talked about last time, right, was this kind of the new shoe that this guy out of Zurich is building. So there, it's I think that and Ken Toronto can correct me or help me. So the new shoe is largely it's got 11 sensors in each shoe, and so it really is doing a great job of kind of monitoring gait in kind of how in balance, and it's learning a lot about what's happening, and then it does actually play kind of vibratory patterns back as
Right,
well, right, Ken? Uh,
right, right.
yeah,
You can set it to vibrate,
yeah. Um,
and they
and
definitely want to go that way to make it more than a metronome.
Yeah. Yeah. So right now it's just I think it's like vibrating to give you kind of a rhythm, right? But it's not playing things into your toes like what we're playing into the fingertips with the glove. Um, and it's a long way from the toes to the
Brain.
brain. I think your toes are way, way less sensitive, than your fingertips as far as kind of densities of receptors. Um, and and so, if I got it right, the way the new shoe folks were going is they really want to coordinate. They want to use the shoe to send signals to the glove, right, to do a better job of stimulating the fingertips. So they don't see like the feet is the natural place to measure, your motion, but they don't see it as a natural place to kind of to act, at least to do the neuromodulation that the glove is supposed to be doing. The shoe can help you keep rhythm. And in fact, they were even, they're using it for, they've got a bigger target than just Parkinson's. They're also helping kind of rehabilitation, kind of post-stroke, post-heart attack, things like this. And so they basically are kind of dialing in different vibration patterns for different illnesses. Um,
And a friend of mine got shoes at the Parkinson conference. He lives around the corner from me, and he kept me posted on them. He's very happy with them.
mm, yeah.
And then I have a couple more questions.
Yeah.
Uh, Occasionally, we're out at night and I can't do it until really late and have fallen asleep. Is it okay to sleep with them on as long as you set an alarm to wake up to take them off?
Yeah, so these are early days, but some of our folks have been able to wear them to bed and still get some benefit from that. So Lauren, you're in that group as well, are you
Yep,
not?
I am.
Yeah, yeah, uh,
It's just I have to find the place to put my hands, my vibrating hands, so that they don't wake me up. So
mhm.
having it on my body, like if I hug myself in bed, that doesn't work. But having them on the mattress doesn't bother me. But other than adapting to a surface, yeah, I fall asleep with them.
And is there any danger in falling asleep and not setting an alarm and having them run for 6 hours? What's is there any detriment having them run too long?
I think potentially, yeah. I mean, so maybe Ken Toronto can speak to this, but I mean, I think just like too much levodopa leads to dyskinesia, so kind of too much glove seems to have a similar effect on some folks.
That's interesting.
And are people are backing down on the Cinemat for that reason and continuing the using the gloves?
Yep.
Anecdotally, yes, yeah, I think, but hopefully in consultation with their neurologist.
And then what do we do after 90 days?
Yes, uh, that's another great question. Yeah, I mean, so that um, this is treating the symptoms, not curing. It's not changing the disease. Yeah, so I think this is a quality of life delaying technique, right? It's stabilizing it's the neuromodulation, right, is modifying um, an aging brain and an aging diseased brain. And so there's there's evidence, a little bit of evidence from Toss's original trial that there are cumulative benefits. The benefits keep on getting better. People could stop, one or two people stopped wearing it for a month without losing efficacy, so without kind of backtracking. So then once they put the glove back on, they were still finding improvement. Um, Kanwar was wearing his for 8 years before he got deep brain stimulation. And he said even after DBS, he still needed some drugs and still needed some glove. It's been a couple of months since we've heard from him. I guess that was his DBS was in September, kind of maybe starting to have some effect in October. Um, it might be nice to get him back. But yeah, I wish I had more concrete answers, right? We're still kind of trying to understand efficacy and um, and duration. And I don't like to talk about it, but even like, is there what's kind of the best target population? Who are the people that we think we can help the most with this technology? Um, I don't have answers to any of those questions.
Yeah.
Yeah.
How about how would we know if we're overstimulating ourselves? What indications would we have?
Yeah. So dyskinesia. And so Ken, Toronto, can you speak to that? I
Yeah, I
think
mean,
you,
basically, Conmar got to the point where he was only wearing the gloves 2 to 3 hours a week, because he sort of built up a surplus of energy, and he found he cut back on the gloves and the medication. But
so,
everybody, it seems like everybody's different.
yeah. I mean,
And
Steve,
that's
have you experienced dyskinesia? Basically, I mean, uncontrolled motion, yeah, I mean, involuntary motion.
Very minimal,
Okay,
very, very minimal.
gotcha.
In
Yeah.
a moment. It's muscular. It's not at a level that feels it's deeper and neurological.
Hmm. But it's unpleasant.
Not particularly unpleasant, but noticeable.
Gotcha. Okay.
So I wonder, is this an indicator of anything else? And it doesn't increase in frequency.
Hmm.
So I haven't been concerned.
Hmm.
But I've been using the gloves twice a day for 2 hours. Now probably pushing 3 months.
Hmm.
And I'm experiencing a little bit of a return of some tremor in my hand.
Hmm.
you saw improvements.
Yes, I think improvement in frequency of tremor and intensity of tremor.
It went down.
Yeah. And I could say I like wearing the gloves. There's something about it that I like. It's relaxing to me. I do when I do it, I get up early in the morning and I go into a meditative practice. So I meditate while I'm doing it. I'll probably fall asleep and get up with an alarm. I haven't had any negative results from it, except my sleep pattern has changed a little bit. So I'm wondering about cutting back to an hour once a day, cutting out the second hour. I don't know what to do. I'm curious about other people. It's just
The
dancing in the dark. I don't know what the data says, so I'm really interested in that.
problem is there haven't been enough people in clinical trials.
Yeah, I hear you.
Yeah. Yeah. We
There's,
are
there,
these
there,
sessions are the data for now, right? And so it's super important that um, they're able to share experiences.
if anything, I think the company that has the most data is Synergy Technologies, because they actually ran trials, and then there was a guy who did videos um, every week or so,
Hmm.
and that's very interesting because he was gave a lot of information. I've never talked to anybody at that company, but it made the gloves for Peter Tass.
Yeah. 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 I mean,
And then they did their trials with the gloves when Peter and them parted ways.
right. And they published abstracts saying they were working on trials, but I've seen nothing on kind of published data for what they learned from their trials.
No,
Yeah. Yeah.
If I could jump in here,
Yes, Ken.
before I started the trial with the Rice glove, I was doing some measurements that I could quantify myself instead of like the finger tap, whatever. So mine was the sit stand. So in 30 seconds, when I was really on, I could do 18 sit stands in 30 seconds. So I measured two 30-second periods, plotted the average, and I did that length, how many I could do after time between doses. So it started like at, let's say I took the dose at 7 a.m. 7:15, I'd do the measurement, 7:30. So I did this for a number of days and got the pattern. And my on time seemed to be good. I could do like 18, maybe 16, 18, up to 3.5 hours. And then like around 4.5 hours, I was down to like 8.
Hmm.
So when I started with the glove, I wanted to see if I could either do more or my on time was longer. And I couldn't do more than 18. Well, I made it 19, but I found my on time was a little bit longer. So it seemed to improve my on time.
And I think that's a common, I mean, or I shouldn't say that it's not an uncommon response that I've gotten from folks with the glove, right? So that I hear about sleep, um, and about balance, and about an extended on time or a reduced off time, right?
Mhm.
Yeah, I
Yeah.
know. I started skipping the last dose of my pills a day.
Hmm.
Pardon me?
I started skipping. I used to do 4 times a day for the carbidopa, and I cut it down to 3. And I
Oh,
had enough
good.
reserve going into the evening.
Yeah. I'm on 5 2 times a day, and I take my last one at like 10 or 11 p.m. And what surprised me is if I got up at like 5:30, which is now I'm talking over 6 hours, I could probably do like 14. So it seems like I'm not using much dopamine while I'm asleep versus if I'm active. Because that's like an outlier. If I plot the curve by dose time by dose, the first dose in the morning after 6 7 hours isn't it doesn't last quite as long, but doses 2 3 and 4 are right, they're almost identical
Hmm.
in terms
Well,
of
Jimmy
the
Choo, Jimmy Choo has the whole sort of video where he talks about how he tailors his meds to his activity level. He's on that ninja show, is it the American Ninja Warrior?
yeah.
And the other thing is, he was in the TOS study. I found out,
It
which is
was.
yeah, it was.
Uh-huh.
It was a miracle. And but he definitely said he would cut back on the carbidopa levodopa, but depending upon whether it is in competition or not.
Got it.
Yeah, so you definitely can zap yourself with carbidopa levodopa when you need more energy.
Has anyone done any research around the 4 hours a day? Is it different if you do 4 1 hour sessions or 2 2 hour sessions or a single 4 hour session?
Nope.
Not to my knowledge. No. So, I mean, the current study I'm designing, at Texas um, is to compare one glove to two. So whether even one glove is sufficient. I mean, you talked about kind of your term as a beginning. You have foot and hand. So there's, I mean, for sure the brain is bilateral. There are two sides, but also as we've seen in our previous studies, there's lots of crosstalk between them. So is one glove sufficient? Is one glove as good as two gloves? And then with one glove or a two glove, is 2 hours as good as 4 hours? And so those are questions we're hoping to answer kind of. Yeah, persuasively. I mean, not definitively, but right now we don't have data on those. Right, people are kind of we're really testing kind of adherence. Are people able to wear them at all? Right. So are they functioning and can they keep to some minimal schedule? Is it 1 hour, 2 hour, and are they getting anything out of that daily experience?
Does anyone else experience fascination, that rapid gait where you can't stop yourself from running? No, because we were wondering if it was correlated with the gloves.
Hmm.
I get that when I get up in the morning. I just sort of stumble around.
No, this isn't a morning. This is when Neil goes for a walk, sometimes he can't stop running, and it's a very short gait, short, rapid gait.
Like a stutter step.
Stutter step.
Mhm. But it's not freezing. It's
It's
forward.
not,
Yeah.
Right. Nobody else has that. Okay.
So,
Lauren?
if I might, so when I was at the Parkinson's Congress, met so many interesting people and a lot of researchers that are doing fascinating work. But one fella, what their approach was sort of stood out for me. And what they're doing is trying to understand the different, understand Parkinson's instead of a cluster of many different things, but understand what things seem to be in common so that they could target solutions to maybe a profile
Hmm.
of of effects. And he thought that that was really going to be the key because the old saying of you meet one person with Parkinson's, you met one person, and all of us here have different, all kinds of different manifestations of the disease, and over time constantly changes and so forth. So I thought that the researchers that are trying to isolate this, that was a worthwhile thing. And I just got something from Michael J. Fox today that was similar to similar effort to that. Matter of fact, I'm going to go get the piece of paper,
Gotcha.
their
Gotcha.
brochure. I'll be
Okay.
back.
Thank you.
Steve, I'm eager to hear about the GLP-1s.
Gotcha. Yeah. So let's move it. Let's move into that. So Lauren will bring back, and we'll catch up with her. So yeah, shall we talk about the GLP-1 business? And so I'm gonna take the screen, um, and yeah. So I can start with the paper. Let's, I guess, in the time that we have, I sometimes just like just to start with. Um, Scientific cartoons are a really great way to, or illustrations is, a better way. So there's, the idea that that GLP-1 can be some type of wonder drug. Well, maybe even before that. So let me back up a little bit. So you see where we are. We're in the gut. Okay, we're in the gut, and these drugs came out of a desire to treat diabetes. So that'll help us explain some of the letters, right? And so with diabetes is related to some dysregulation in kind of in glucose levels in blood, right? And so there are kind of two hormones that um, keep the sugar levels balanced in the body. And one is insulin when sugar goes too high, and the other is glucagon when sugar goes too low. And so there is this amazing balance, that can go into imbalance in diabetes, um, when blood sugars are not properly regulated. But the idea is there is insulin when there's too much glucose and glucagon when there's too much sugar. And for many many years, this was an amazing discovery. For many many years, it was just understanding that imbalance. And then in the past, well, in the very recent history, it was found out, that the genes that were coding for glucagon, this one hormone, were also generating other peptides that are also acting like hormones. And so GLP is the glucagon-like peptide. A peptide is just a small protein. And again, peptides are thought to be kind of building blocks. They're not major players. Um, but then, that's this. So they got named peptide in the beginning, and then it's kind of its role in human metabolism has just kind of blossomed as people have discovered, its amazing effects, right? And so this is just a small illustration of its kind of positive effects on liver, on the gut, on pancreas, on the stomach, on the brain. We'll come back to that, on heart and vessels, on kidneys, on the immune system, on skeletal muscle, and then on fat, right? So it's not just a diabetes drug; it's also a weight loss drug for its ability to handle body fat or to remove body fat, um, with somewhat minimal side effects. But the key thing is somehow its ability to lower inflammation. Um, and then another key thing here, which would be a great thing to keep on talking about, is, and so it doesn't seem to be, at least listening to folks that have used this as a weight loss drug, it's not just its ability to help metabolize fat, it's its ability to actually shut down or diminish food noise, right? People that are wishing to lose weight talk about this kind of insatiable noise in their head, kind of driving them to overeat, and how these drugs are basically just kind of silencing that noise. Silencing that food noise, the food noise has a lot to do with reward circuits, and reward circuits have a lot to do with dopamine. These are different dopamine centers than the ones responsible for Parkinson's. Um, but the fact that it's by by lowering food noise, it lowers food intake and lowers water intake. It lowers the desire for those, right? And desire is definitely a dopamine um, player. But the key thing of the biology, or the key thing that really that why Parkinson's researchers are eager to study GLP-1 receptor agonists, is that it leads to neuroprotection. And um, once symptoms occur from Parkinson's, typically 50 to 70% of the dopamine cells have been compromised. And so like the rush is on to protect the what population is left. So anything like red light therapy, which leads to better cell health, or in these cases, GLP-1 receptor agonists, any of those are seen as kind of the more we can protect what cells are there, um, then the longer we may kind of sustain a higher quality of life. Um, and so I like this graphic just for that. So basically, there's like small Manhattan projects going on to understand how GLP-1, is affecting the health of these organs, and then also the health of diseases, right, that are attacking these organs. So we're up here in the brain. Um, and so that's the nature of the paper that I want to talk about. Um, and so, and you can see even the title of the paper is largely kind of neuroprotective effects of GLP-1 class drugs in Parkinson's. Um, Yeah, and so there's maybe another thing. So the glucagon, right, is the thing that works when kind of sugars go too low. So this is a one extra hormone that has receptors. And again, we think about kind of food regulation being down in the gut, but everything's driven by drives up in the head. So the brain seems to be full of receptors for for GLP or GLP-1. There's a couple other peptides in that group. Um, so the brain is full of those. The natural thing that actually the natural GLP-1 only lasts for 2 or 3 minutes in the bloodstream. So the race was on to find things, bless you, Laura.
Oh,
Yeah,
sorry. Thank
to
you.
find drugs that could act, at those receptors, but that could live for much longer, you know, in the body. And so that was discovered in the saliva of Gila monsters, because Gila monsters they can go days without eating and still be able to regulate their blood sugars. So something was happening for a long time, to kind of extend the life of kind of blood sugar regulation. And so that's led to more and more kind of long-acting receptor agonists. So it's something that can trigger the GLP-1 receptor, but this doesn't have kind of the short lifespan. Okay, and so I've just more or less um, try to um, try to highlight various parts of the texts, and so. Just a few places where I've done that, and I can make this a little bit bigger, and I can try to hide some of my Zoom screen business. Um, uh, and so just to be clear from the beginning, right? So the brunt of this is kind of neuroprotection. as you know, to kind of keep cells as healthy as possible and Parkinson's as long as possible. Um, and then largely the connection, of course, all this research came out of diabetes. And so there's a significant association between Parkinson's and type 2 diabetes, possibly due to shared pathological mechanisms such as insulin resistance. They talk a lot about chronic inflammation and mitochondrial dysfunction. Okay, and so that's in some sense, I think probably the real smoking gun is this mitochondrial dysfunction. Um, so what they're hoping for, right, is novel insights into potential therapeutic strategies. And like I said, the the current clinical trials and these kind of this class of drugs has been mixed. So we don't yet know either the right population to get back to Lauren's kind of notion, right, that we kind of need to target treatments for certain phenotypes, you know, of people suffering the disease, or we need to kind of tune the way I've been talking about the glove, or my hopefulness about the glove is that we can tune its parameters to the individual. Um, but again, I could be overly optimistic. Um, so kind of in more detail, type 2 diabetes is considered one of the risk factors for Parkinson's. Um, People with type 2 diabetes have significantly increased risk of PD. Um, and again, mitochondrial dysfunction is kind of seen as one of the common pathways to both drugs. Um, it's a review, so in that sense, like the science is not very deep, but it's broad in the sense that they cover lots and lots of different subjects. And so I really wanted to get into, um, you know, the one that focuses the most on things we talked about the most, um, is this long highlighted paragraph. And so the cells that create dopamine, those neurons are in substantia nigra. So, at one of the bottom ganglia and the basal ganglia, and the part that they work on is in the striatum. So these are really um, these are the cells that dump dopamine into the basal ganglia. And we talked before that they've got higher energy demands than other cells, making them more susceptible to mitochondrial dysfunction. Right? And so these are again these are neurons with about sometimes 100 times more synapses than any neighboring cell. So they're doing like 100 times the work. Um, and so they're on this kind of knife's edge of needing a lot of energy, and especially in Parkinson's and some compensatory mechanism. So not only are they the hardest working, but if 50% of their neighbors are no longer working, then they're doing extra duty. Um, so and that's a recipe for disaster. Um, and so some studies have shown reduced expression of major components of the electron transport chain in the striatum, frontal cortex, and substantia nigra of Parkinson's patients. And so I'd like to go back to a previous discussion of ours, because I know there's lots of jargon in here, so I want to take us back to another graphic. And so let me try to grab that here. Um, so this was our agenda for, yeah, Joe, just a little bit more than a month ago. We looked at red light therapy. Um, And again, if we follow the evidence, that the cells that die in Parkinson's are starved of energy because they're some of the greediest cells in the brain, then where does energy come from? Energy comes from mitochondria. That's the most prevalent kind of organelle in any of the neurons in your body. These are the energy factories. And so there's just so much research on how to boost their production. And to make ATP, there is this electron transport chain. So there's a transport from complex 1 through complex 4, leading to a great imbalance in protons in this inner area. And those protons then flow across ATP synthase and make ATP, which is the energy currency of the body, adenosine trisphosphate. So in comes ADP, something with two phosphates, and out comes ATP, something with three phosphates. And that final phosphate bond is so energetic. That's what's used to transfer energy to the rest of the hungry body. And so our discussion of red light is that it was discovered that the third enzyme in this complex, we could boost its output by having it absorb light in a certain spectrum. Okay. Um, so kind of, infrared and red. So it kind of two different wavelengths. Red light, if it's able to get to these whatever mitochondria it gets to, can boost their productivity. And so the paper we're talking about today, the GLP-1 receptors, seem to have a major impact on complexes 1 and 3. Okay, so 1 and 3. And so again, any ability to kind of target the productivity of this chain will lead to more energy in the mitochondria, which will lead to more energy in the cell, which will lead to healthier cells. That's the that's the mantra or the mindset behind what's discussed here. Okay. So ETC is the electron transport chain. These are these four enzymes um, in the inner membrane of mitochondria um, that work that they need basically, but all they largely need is oxygen to kind of get them started. But there is this shuttle between these four enzymes. And so complex one is the first enzyme in the chain. Okay. The mitochondrial respiratory chain complex. Being crucial component located on the inner mitochondrial membrane, complex one dysfunction is considered a major factor in pathogenesis, the death of cells in Parkinson's. Reactive oxygen species in cells mainly originate from mitochondrial complexes 1 and 3. Okay? And and so the long story short is what they find um, is that let me remove this guy. Sorry. Um, what they find are these GLP-1 receptor agonists are able to boost the effectiveness of complex 1 and 3. Okay.
Mm-hmm.
And which are seen to be, the things that are the real, uh, sorry, um, I'm removing the note taker. Sorry, I just lose my place in the and so and how do they know the connection to Parkinson's? And so we spent a little time in the past on kind of environmental insults, and some of those environmental insults come from kind of bad drugs like MPTP, um, but also kind of herbicides and pesticides like rotenone that's in here as well. Okay, all these leading to reactive oxygen species, all of them leading to inflammation. These are all related to mitochondrial dysfunction. And so that one of the simpler kind of graphics that they have in here, right? So this is kind of related. This is now kind of zooming out on the bigger picture. Um, but they see that kind of insulin resistance, you know, building up either by diet or by genetic predisposition. There's lots of ways where insulin resistance is occurring. This begins to exacerbate mitochondrial dysfunction. That leads to an increase in oxidative stress. That oxidative stress promotes the aggregation of alpha-synuclein. These are the proteins they misfold that again have a mysterious role in Parkinson's. On autopsy, the cells that have died are full of these tangles. It's still not understood whether these tangles occurred as kind of an immune response or if this is really what's strangling the cell. But the end result is that you're losing dopamine. You're losing cells that make dopamine. And again, without dopamine, we've now discussed for the past half hour the number of side effects that the amount of kind of motor dysfunction and for even cognitive dysfunction that come from lack of dopamine. Um, and so that's kind of the Parkinson's connection. And let's now read a little bit about what this thing can what it's up to. This glucagon like so GLP, glucagon like peptide one. It's a family of things that were named incretins as a combination of two earlier words. They're polypeptide hormones secreted in the gut, and they promote insulin secretion. Um, there's a relative named GIP. Um, so I won't try to read all these signs out for you, but GLP-1 and GIP are the primary members. Um, they're created in the gut, right? And they bind to specific receptors promoting insulin release. So that's kind of the low level. That's all happening in the gut. And then kind of the miraculous thing, right, is that not so miraculous. We understand how this works, right? I mean, the gut still hopefully is under kind of the control of the mind, and we can control what we choose to eat. But for people with food noise, that's much more difficult. And so this stuff is not just in the bloodstream and the gut; it makes its way to the brain. Okay, so GLP-1 and its analogs on the nervous system. So particularly, it crosses the blood-brain barrier. Um, and these receptors are widely distributed in the central nervous system, especially in regions related to appetite regulation, to memory. Um, again, I think for most of us, somehow smell and taste are some of the strongest memories that we have, right? So, right. I remember my grandma's perfume from when I was 3 or 4, I guess. Um, and so memory and learning happen in the hippocampus. Appetite, kind of the drive happens in the hypothalamus. Um, the brainstem is kind of a, lower level actor in all of this. It's also thought, and this isn't developed in this paper, right? But it's one of the standard hypotheses, right? Is that really the Parkinson's begins in the gut, travels up the vagus nerve to the brainstem, and from there kind of begins destroying the most vulnerable cells. And those are the highest energy ones, the ones that need the most amount of energy. So by activating these receptors, GLP-1 exerts various biological effects in the central nervous system, including promoting neuroprotection and neurogenesis. Um, the neurogenesis, I mean, we've talked about stem cells before, but these were stem cells that were kind of grown in a dish and then implanted in basal ganglia. Uh, as far as we know, there are no stem cells naturally occurring. There's only a couple places in the brain with to promote neurogenesis, and one's the hippocampus, the other's the olfactory bulb. So, but if we are able to graft cells um, onto the basal ganglia, then having something that protects them as well as something that helps them grow again is something that we should take seriously. Um, so those are the main points I kind of wanted to cover. There is one kind of you know, one more kind of alphabet soup slide for all the pathways that happen when these receptors get activated. Um, but the key thing are these arrows again. So basically, oxidative stress in the cell goes down, inflammation goes down. Apoptosis again is a scientific word for cell death, and so the death of cells is mitigated. Um, Energy utilization and mitochondrial activities are going up. And again, and I basically said they're targeting kind of earlier enzymes in the electron transport chain to ones that we had at least talked about in previous Zoom sessions together. Um, yeah. So, I mean, I found this paper, I mean, it's largely on the hopeful side, right? It's arguing about its ability to boost energy supplies in cells that need energy. So now finding kind of the right dosage of this and studying it in the right population, um, this this is the challenging part, right? So if we do go on to say Michael J. Fox and look at clinical trials um, for GLP-1, so there it's a mixed bag. So um, all they're saying is that they've yet to find kind of the right treatment, but they're still pouring a lot of money into its research. And maybe without getting too technical, I hope that I've tried to help you see that the benefits of GLP-1 is on energy production. Diabetes is a metabolic disease about imbalance of metabolism. PD is also metabolic in the sense that these cells are starving for energy, and we want to keep those cells, with the ones you have, healthy as long as possible. And so by kind of treating that electron transport chain, kind of like red light therapy has the potential to do, that together perhaps these therapies, can help the current cells you have last longer, and the ones that are on their way out even last longer. I hope you found some of that useful, or can,
Very.
and again, or that you can take my highlighted passages and dig deeper. It's a review paper, so it has um, a long biography. It's fairly recent. It's only a couple of years old. It has some of the references are foundational references when people like were first discovering like the role of the mitochondria in Parkinson's. And I've gone much too quickly over all those steps.
Well, I had a comment, Steve, or a question really.
Yeah,
But I've been having these Ozempic shots for maybe a year and a half or so, and I didn't know I was doing it for weight loss, and
yeah,
it's been somewhat effective. Super interesting experience. But now, recently I ran across that article that I sent you,
yeah.
and it was really interesting. All of this that you're telling us, and I'm glad I'm on it. I would say my Parkinson's symptoms seem mild compared to many, and glad for that. So it's just the article, which I can't really reference or quote very well, but the title of that article wasn't. It was from Scientific American, I think. I forget, but it said that it seems like Ozempic may be able to rewire the brain. So that was intriguing, and I'm not sure we've been able to really, uh, in what you've told us, if that really corresponds or if rewiring has some other
Yeah,
connotation.
yeah. I think that's I couldn't I tried to trace down such a claim, right? And I mean it's a great claim to make. Basically, I mean that's the claim that Toss is making for the gloves, right? Is that the gloves rewire the brain, right? So that the Parkinsonian brain is hyperconnected, especially in cortex, and by by playing these kind of but by teasing the fingertips, we're getting the brain to kind of let go of some of those connections. Um, and so and TOS does provide some kind of EEG evidence for that. The fact that Ozempic is kind of rewiring the brain, that that I could not find kind of real evidence. The only real evidence is kind of the anecdotal stuff, the food noise, and the food noise is fascinating, and it does have a dopamine connection, and so it is changing people's drive, right, for their appetite, right, for food. Um, so in that sense, there is some rewiring going on, but it's right. It's largely just suggestive. I had not been able to kind of um, it's not like talking about cell health and mitochondria and identifying, who are the actors. Um,
Well, it may be about ghrelin. Maybe what they're referring to is the hunger hormone, rewiring hunger signaling in the brain.
mhm.
That's probably what they're referring to.
Maybe so. My experience is, and the doctor asked me, "Well, how are you feeling? What's going on?" I go, "Well, nothing sounds very good."
Uh-huh.
Food, as far as foods or the idea, well, pizza, whatever, nothing really sounds good.
Yeah, that's what got rewired is
Mm.
the appetite signaling.
Yeah, so that's where, and I didn't get into that because that's where the hypothalamus gets in too, and so that's and connecting the hypothalamus to Parkinson's is not a jump I know how to make. So one way to figure out where GLP-1 is acting, right, is to kind of make a map of the brain and where are the GLP-1 receptors, um, and again, these are microscopic little beasts, so they need to be tagged and light and lit up and then counted. It's an Olympian task, right? And so these are also still early days for that, but they have been identified in brainstem and hypothalamus and hippocampus, where where food memories are associated, with other memories, other episodes in your lives. Um, and so whether it's whether it's just really rewiring or if it's just basically kind of reprogramming your hypothalamus to kind of lower your drive. Um, has it lowered your drive for other things, Julie? Is it just targeted to food, do you think, or is there lethargy involved, or
I can't really tell. I mean, there's so many variables
yeah,
in
yeah,
my life and my experiences. I can't really make a connection like that, but it is interesting. I think you just said a minute ago that maybe the gloves, we could say that maybe what they're doing is possibly rewiring the brain, or define it in a different way. Maybe it's just sending different signals, right, to the brain. So it's interesting stuff.
yeah. I mean, I think of the glove as somehow noise canceling headphones, and so it without dopamine, if the theses are right, if there are too many connections made in cortex, um, then the idea is to kind of somehow break these connections, but also that with too many connections, then rhythms are set up. If too many cells are talking, then they can fire they can fire in synchrony, and while they're firing in a rhythm, it's hard for you to actually interrupt that to voluntarily move. And
Hmm.
so you want to somehow squelch those rhythms. The best way to squelch those rhythms is by kind of disconnecting the people in the orchestra, by
Hmm.
rewiring the brain. Um,
Hmm.
and that's the evidence that kind of Toss provides. Again, it's indirect. He is not inside the brains watching kind of synapses disappear. His most convincing things are kind of numerical experiments, and kind of a brain in a computer program. Um, but that computer program gave him the sequence that you feel on your fingertips, right? That he discovered that sequence, that timing sequence, as something that best disconnected cells in a computer network. Yeah.
Steve, I have a question. This is my red light device.
Uh-huh.
I
Yeah.
don't know if you can see it. What is the current best practice or guidelines to how to use it for Parkinson's and where to apply it and for how long and how often?
Yeah. I guess I don't have the direct answer to that. I would go to the Michael J. Fox. So I've been using these Zoom sessions just to kind of expose treatments that are out there, but I'm not a medical doctor. So my hope is that these could spur conversations among folks that have experimented with these things, and or that it could be a conversation with their neurologist. I hate to pass the buck. But I want us all to like learn more about Parkinson's. And I can't really promote any of these. I can't even promote the glove, right? I mean, we've got some success with the glove. I feel that it's helping some people, and some people are helping me, help others. Um, so just kind of casting a wide net. But then my knowledge then in each of the nodes is fairly shallow. I apologize. So as far as best practice, I learn a lot from the Michael J. Fox. I sometimes I like to go a little bit deeper than them as a scientist. I want to dig under the hood. So a lot of things they're putting out at a fairly kind of superficial level, but they also provide, references for how to go deeper. Um, and and I think the references that I shared there was, again, maybe it's just kind of clinical trials without really talking about best practices. Um, but that it was a Canadian group doing Parkinson's and red light therapy that we looked at last time, or on the May 10th video. So I would just kind of follow that paper trail down to try to understand best practice. Um, but I also feel like these treatments are new and experimental, so I think a lot of it's going to be self-taught. Um, are you finding any benefit from that? You were using the light for other reasons, or was it
No, it's for
for
Parkinson's. Yeah, I
Parkinson's?
used it. It was boy, I got it at least a year ago and used it consistently, and then I stopped using it for a while, and now for the last month and a half, I have been using it. Um, and the gloves. So I'm not sure what is working, but there are parts that I feel a little more grounded.
Mhm.
I think the symptoms, the timing has changed in the symptoms, so it's not so constant all the time.
Mhm. Good. Good. Lauren, you were going to return. I know we kind of I know you left the room and we moved into the next chapter, but you were going to share something with us.
I can't find it.
Okay, gotcha, gotcha.
It came with today. I got this Michael J. Fox, Fox Focus on Parkinson's,
Hmm.
and I think my memory is that there was also a one-page thing, like a flyer thing like this kind of thing,
Uh-huh.
and that it was that I read.
Gotcha.
So I'll forward it on if I come across
Okay.
it again.
But I mean, I think that is good kind of natural advice to realize, that again, we say it all the time, right? That each Parkinson's patient is quite individual, and that we're not gonna find the treatment that's going to be broad spectrum. Um,
Right,
yeah.
right.
So we really have to begin. Um, I don't know. I just as a teacher and as a parent, I don't like sorting people, But um, so
I know. My first reaction was, how on earth? I have four things maybe in common with Julie out of 100 things. You
yeah,
know what I mean?
yeah,
How close are we in our experience? I
yeah.
don't know how they're doing it, but it seems that it's a broad um, a broad topic that's being pursued by a number of different scientists. So
Yeah,
we'll see what
yeah,
comes
yeah,
from it.
yeah. And there's a million people, a million Americans. Every 5 minutes, there's a new diagnosis, and so that if we just got better at collecting data, we would be able to do this. Stu has had his hand up, and so I mean I want to hear from him. Stu?
Yeah, thanks. I just on the sugar subject and insulin and all that. Has
Uh-huh.
anybody noticed anything weird when they eat sugar after the end of a meal, like any sneezing or any reactions to that kind of stuff? I just wonder if it was just me. It seems like a weird thing, but I seem to get my symptoms seem to get worse when I have a lot of sugar intake in the short term. Oh, okay,
Anybody notice? Yeah.
thanks.
Thanks, Stu.
Thanks for the gloves. I appreciate you.
Okay. It's 9:20, friends. Or at least, yeah, sorry, I'm in Milwaukee these days, so it's a um,
8:20.
8:20 for yeah, mountain folks.
Steve, thank you for doing that after your long day.
Well, no, it's
Much appreciated.
yeah, it's important to kind of to keep up with each other. So I appreciate you guys supporting one another. There's some new folks, kind of coming online that can learn a lot from you guys.
I don't know where I would ever find the information that I get as a result of being part of this group.
Uh, Very
Super
valuable.
helpful.
Yeah.
Yes, very valuable.
It's just great. I really appreciate it. I'm over in Atlanta visiting my granddaughter, but so it's 10:20 here, but
Gotcha. Okay.
very glad to be part of it and glad to stay up late and be here. So
Okay.
it's invaluable, really, and just to feel connected and
Mhm.
to get some of the science behind it all and get the sense of who the people are, some of the people that are working on it, what they're thinking. It's just great.
Yeah, I
Cool.
want to ditto that too. I really appreciate being available and having you all available because I have so many questions that are unanswered and I just keep going back to just using my own experience and it's giving me the confidence to do that. And I can report back and hear what you guys are saying because we're all experimenting really.
Yeah.
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 I
So
guess
thank
it's a
you.
good time to have Parkinson's, in a weird way.
Don't go
Well
overboard.
said. Well said, Lauren. That's the way to frame it.
Well,
That's
I'll add in today's society to have an opportunity to interact with people, and you're not an AI illusion for me. So I appreciate the human to human contact that we have with each other. It means a lot too.
me too. Yeah.
Yeah,
Yeah. Well said, Steve.
absolutely.
Well, I'm excited for you guys to meet two young idealists in 2 weeks. Um, so, and then you saw it kind of showed up there, Glove, a very different model than we have, and so I'm really hoping to um, to kind of uh, better focus our collaboration. So rather than competing with with another nonprofit foundation, that
Yes.
we can do something better together. So
Absolutely.
yeah.
So another question, what's the best way to order another pair of gloves if I'd like that? A second pair.
Um, yeah, you can just go back right onto the same website and make a second order. Yeah. Yeah.
Okay,
It was
great.
great. Yeah. 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 Some folks have done that. Yeah.
We're going to stay on with you,
I'm
Steve.
gonna say yeah, yeah. So I'll
Could I hang out too? Because I've got an interest in that German company.
sure, sure. Yeah, yeah. But I think I'm gonna try to help kind of I think Neil and Connie are still having troubles with some wires in the glove. And so I'm probably
Okay.
I just want to take a look at that and then I'm going to ship you guys a new pair, right? But I just want to make sure that I understand what's going on. But yeah, Ken, you're welcome if you got
I just
questions
wanted to
or
know what kind of
Good
progress they
night,
made with
everybody. I'm going to say
trying to
goodbye.
contact
okay. Good night,
Bye,
Steve.
Steve.
Um,
that
Hi,
company.
everybody.
um, bye, you guys, please. Yeah, so I'm just going to turn off the recorder then as well because it's quite late.